Hey, hi everyone. Welcome to my YouTube channel. My name is Sunny Savita, and in this video, guys, we'll discuss one more important and very useful concept of the re-ranking. Yes, guys. So, I was talking about this retrieval and the re-ranking with respect to this rack pipeline. I already discussed so many topics, so many things. If you will go and check with my YouTube channel, definitely you will get it. So, first of all, let me show you the complete syllabus. The syllabus basically which I covered in my recent days. So I started with the re-ranking. Then I explained you the importance of the re-ranking. Then I discuss about the re-ranking from scratch using this sentence transformer and this BM25 API. Then I discussed this re-ranking using cross-encoder, and I discussed about this cohere API and all. Then I came up with some advanced concept like I discussed this lost and middle phenomena. I discuss about the merger retriever, long context reorder and all. Then I discuss about this rank fusion. Yes, this was the very much important, guys. And by using this rank fusion, we can create a very robust pipeline. Yes, very robust rank pipeline. Now it's time to discuss about this flash rank or fast rank. Okay, so what is this flash rank? Who is created this flash rank? Where you will find out this flash rank, right? The code and all everything we are going to discuss in today's session. So let me show you my YouTube channel, guys. So here, if you will go and check with my YouTube channel, you will find out all the video related to this re-ranking and all. Not only the re-ranking, if you will scroll down, so many video with respect to this RAG related to the different framework and the databases. And now I have created one more new playlist. The name is Advanced RAG. I already recorded 6 video. This is a seventh video of this particular playlist. Now I will record. Now basically you will find out few more video with respect to this advanced rag and all. Because after this reranking, I'll be working with the retrieval and all. Okay, and then we'll come to the chatbot and the different other topics. Which is I'm having the complete list. So don't worry, I will share with all of you the complete plan and each and everything. And I'm planning a couple of live session as well going forward. So if you haven't subscribed the channel, please do it. And if you will go inside the live session, see already I have covered one project. Okay, 4 months back actually when I started my channel at that time itself. Now I'm planning one full-fledged series in the live mode itself. So the session won't be too long. The session will be as small as possible, but yeah, that too will be in a live. So please guys, please subscribe the channel and please hit the like button if you're watching to the video. Please share with your friends and colleagues and all whoever is required to this kind of video related to the generative AI chatbot rag. Okay, or soon I will be uploading few more video. Okay, so I'm thinking about the basics and the fundamental of the deep learning NLP and the computer vision, and also that you can familiar with the basics as well. Then machine learning, Python, okay, object oriented programming, modular programming, industry level project and all, everything I am planning. So if you haven't subscribed, please do it, guys. It will give you the benefit. And yes, if you are sincere with your learning and all, definitely you can land to your dream job as well from learning here, because I'm covering each and everything to the industry level. Okay, so yeah, let's begin. Let's start. So first of all, let me show you this particular project. Okay, the project name is FlashRank. So this person has created this project. The person name is Prithviraj Damodar. This person actually is a quite amazing one, and he's a very well-known person in a open source community. If you will go and check the repository of this person, right, you will find out so many stars and folks. Okay, and the different framework and the different project with respect to the different things, right? So definitely you can check out the profile of this person, YouTube link, okay, and the other repositories and all. So he has created one more repository. The name is a Flash Rank. This is the repository basically which we are using for what? For the re-ranking. Yes, guys. If you don't know about the re-ranking, don't worry. I will explain you about the re-ranking. Now, what is the different thing actually we have inside this Flash Rank? Why we are using it? And one more thing, guys. This Flash Rank actually it is available inside the langchain as well. Yes, this integration is there inside the langchain. I will show you in some time. So what is a like important thing inside this FlashRank? So first do one thing, just check out with the README file. So inside the README file, the person has mentioned each and everything. So he has mentioned about four type of model. First is ultra right. Okay, four type of model. So nano, okay, then medium, then large, okay, and one more type of model. I will just show you. Now, apart from this one, guys, here you can see the feature of this particular project, feature of this particular repository. It's ultra light, super fast, okay. It's concise and it is based on the SOTA cross encoder and other model. So, cross encoder I already discussed. Cross encoder itself is a repository which you will find out inside the Hugging Face, and there you'll find out the different type of model. Okay, cross encoder actually we use for the re-ranking and all, and yes, it is very much important. And now guys, this person also use something from the cross encoder itself, but the model is the lightweighted model. Now one, let me clarify one thing over here. So whatever model you can see over here, this ms macro tiny word, ms macro mini lm, okay, this rank t5ln, ms macro multiword, this model has not been created by this person, right? This person nothing created anything, nothing trained anything from scratch. This person aggregated everything inside his project, okay, and this a particular package we can use inside our application. And why we are using it, guys? Because it is giving us each and every combination of the model at the single place, right? And here the main thing of this particular repository you will find out. So it is ultra light and super fast. Why, guys? Because this by default model, this MS Macro Tiny Word model, it's a super light model. And if you will see the size of this particular model, now really you will be surprised. Even you can run inside your system as well. The size is just around 4 MB, right? If you will go and check related to this model now, so just do one thing, try to copy it and then paste it inside your browser. So once you will do it, guys, here you will get the each and every detail of this particular model. As I told you, it is already available inside the cross encoder repository. And this model actually cross encoder for ms macro. Just click over here, just click on this particular link. You'll find out this like model actually has been developed by the Microsoft. Yes, so this is the data set, guys. Micro machine reading comprehension, this is the data basically they have used for developing this particular model. You can read the complete detail and all everything basically they have provided over here. And yes, this person is using this particular model, not this one, guys, this one. This person actually it is using this particular model inside their own a project. So directly we can read it, directly we can use it for what, for the re-ranking. I hope the thing is clear. Now if you will scroll down, guys, here you will get the complete implementation and all. So I was talking about four type of model. One was the nano, small, medium, and larger. Sorry, I forgot. So one was the small, then medium, right? And apart from this one, he has given you one example as well. So let's say if you have query, and here is your retrieve answer, right, which you are retrieving from the database. Now what you can do, you can pass it to the you can pass it where you can pass it to the ranker request, okay, this all the thing. And then finally you can re-rank it. So what you will get, you will get the re-rank response over here, as you can see, right? So this is the complete implementation the person has given to you. Now you can use this flash rank, means this re-rank anywhere inside any architecture, whatever database, whatever embedding model, sorry, whatever database or whatever technique, whatever architecture you are creating, anywhere basically you can use this particular model, this particular library. I hope this introduction is pretty much clear to all of you. Now coming to the next point. So first of all, guys, let's try to revise about the re-ranking, and then I will show you some more interesting fact, and finally we'll start with the practical implementation. Okay, so first of all, guys, here this is the architecture of what? It's the architecture of the, tell me, rank, right? So where this re-rank lies, tell me, guys. Here, I think I already explained you in my previous video, but don't worry. Again, let me give you the quick overview, quick recap of it. So I have a data. This data could be anything. Now this data I'm dividing into the multiple chunks, as you know, right? Now after this one, I'm performing embedding. Okay, embedding means numerical representation of the data, and then we are storing inside the vector database. This is my database. Got it? Then here is my user, which is asking the query. So the query actually is going to be converted into the embedding. Now after the embedding, guys, what I'm doing, I'm performing semantic search based on this like query and all. Okay, and here is my record. Let's say here I in total I am having n number of records. So n records. Now let's say I am retrieving k is equal to 10 records. Okay, so this is called my rank result. Now after this rank result, actually I can perform one more retrieval operation. Okay, and this is called re-ranking, guys. This one. So what I can do, I can perform one more retrieval operation. Now here I am having this. I collected 10 document. Now let's say here I am just collecting 5 document, and this is called the re-ranking. And here again, what I'm doing, I'm performing my similarity search and all. So my query is here, right? My query is here, the same query. Here is my retrieve result, this particular result. Okay, and then again I'm doing a similarity search and all whatever, and based on that, this is my refined output. It is also called two-stage retrieval. Then finally we are passing to the LLM, and this is my generation process. I hope this architecture is clear to all of you. Now coming to the implementation of it. So first of all, guys, let me show you one thing. So let me show you the uh, like langchain implementation of this particular flash ranker. Now what is the meaning of the flash here? So guys, flash, it is representing to the fast, right? So he has aggregated the very fast model inside his library and all. The model basically it's a quite like a small model, and definitely we can use it for the re-ranking and all, even over the lower configuration. That's why the name is flash re-ranker. So this implementer is all like it is also available over the langchain as well. So it's a complete interface, okay, abstract class and all. And now if you want to check the low level coding and all with respect to this flash rank and all, so yes, I figured it out that as well for all of you. This is the like file. Basically you will find out over here inside the langchain GitHub. So the file name is flash.rerank.py. Now let me scroll down. Here you can see by default actually they are using this MS macro multibird L12 model. The same model which I shown you, the smallest and the fastest model, right? So yes, you can see the complete low level coding and all. Definitely you can check out if you are willing to do it. If not, then you can use the code and all everything from here. Okay, from the abstract class and all, right? But yeah, we are going to use from here itself. But just to understand it, we can check out the code as well, the low level code. So yes, this repository is clear. This is also clear. Now guys, this is also clear, this MS macro passage ranking and all. Now let's come to the practical implementation. Here, guys, inside the notebook, I kept a little bit theory as well, so that you can easily understand whatever point I was discussing there inside the like while I was explaining you this GitHub stuff and all. So there is four option of the model. First is nano, then second is small, third is medium, and the fourth one is the large. So the size of the Nano is 4 MB, which is very fast compared to the other model because it is quite small. And definitely, I will show you once I will run it. I will estimate the time and all everything. Then the second one is a small, which is having 30, the size around 34 MB. It is slightly slower with the first one. And guys, it is giving you the best performance as well. Okay. And now the next one is what? Next one is the medium, 110 MB, slower model with the best zero shot performing, okay, a ranking precision. The large one 150, more than that. So here slower model with a competitive performance, ranking precision for 100 plus a language. So yes, we know that if the model size is going to be huge, in that case definitely it will take it will take much time. And here the in the rack pipeline, guys, anyone can create a rack pipeline, even the noob guy. But the main challenge is the production. So whenever we are putting into the production, how fast actually it is retrieving a data. So definitely we can test out this particular model, we can check or we can put it down inside our pipeline, and let's see whether it is working fine or not. It is based on the experiment only. There is no hard and fast rule that you have to use the same model or not, right? Now coming to the next one. So here ultra light, super fast, cost efficient, based on state of art model and all, sleek model for the efficiency. See, these are the model which you can use from anywhere else as well, means from the from the main repository as well. But this person has aggregated each and everything, right? Here inside its repository, this Prithviraj Damodaran. You can check out with the code. So he has given you the complete code inside this particular folder. You can read about the code and all everything, and you will get the complete end-to-end idea. Now coming to the next one. So here, not this one, guys, this one. So first, I'm installing the library. Library name is FlashRank. After installing the library, what I will do, I will so this is my additional code just to like format my output and all. That's it, right? So here I'm picking up page content and I'm just formatting it. Means I'm just segregating the retrieve output. In some time you will get the functionality of this particular function. Now here's my query. My query is how to speed up LLM, and this is my retrieve operation. Already just assume that we have already get the answer. Okay, we already perform the similarity search, and based on that we are able to get how many retrieve document, 5 retrieve document. Now this is my import statement where actually I'm importing this ranker and this Reranker request. Okay, so this is my function, guys. Where actually what I did, I kept. So what I did, guys, here you can see I kept a couple of conditions. So if choice is equal to nano, means if my choice is the smallest model, then I will run it. Then if my choice is small, okay, I will run this particular model. I will load it. If my choice is medium, I will run it. This one, I will run this one. If my choice is larger, I will run this one. And here you can see the further code, means I'm passing my query and passage, and then I'm going to be re-rank it. Okay, here is my result, and then finally I'm going to print it. That's it, and I'm going to return it also. This is my simple method just to show you that I can use each and every model, okay, from the FlashRank. So this is the core code from the GitHub itself directly, which I took from the README file only. If you will go and check now inside the README file, I just took it from there itself. Okay. Now what I'm doing, so after running it, see here, if I'm running this one not with the nano model, so it is re-ranking all the document. So ID 4 is coming at the first place, then ID 5 is coming, okay, then ID 3 is coming, then ID 1 is coming, and then ID 2, right? So it is re-ranking all the document, and here you can see the estimated time. So the estimated time is just 74745 millisecond. ms means what, guys? Millisecond. Okay, so this is the estimated time, wall time, right? When I see this time actually it will give it to me the wall time. If you want to check, let me show you with the different code. So just do one thing, just take it and write print over here, print, and here you can print anything, let's say sunny. So it will give you the wall time. See, it is 8.16 millisecond. With the CPU and all everything, basically it's trying to calculate and it is giving you the accumulate time. So now let's look into the other model. So here I'm passing the small model. It is again giving me the re-rank document. Okay, 4, 3, and then 1, and then 5 and 2. This is the ranking of the document. And here you can see the timing, it is taking around 2.6 because it is a little larger model compared to the previous one. So that's why it is taking a huge amount of like little more time. Now if you will check with the medium model, so a medium model actually it is taking 10 seconds, right? And here you can see the re-rank document. So likewise you can compare the time and you can reduce the latency. Now I haven't tried with the large model and the other model, basically because the other several other model is also there inside the repository and all, because I know it will take time. You can check out it and you can estimate the time. One larger model I run it from the cross encoder itself. So it was taking around for me 10 to 12 minutes. Okay. So yeah, this much of time they might also take. So the latency and all, it is very huge concern over here inside the RAG pipeline. If we are going to be like performing the different other operation like re-ranking or different other type of retrieval and all. So definitely we should keep in our mind that we have to reduce the cost, we have to increase the performance. Okay, then only we can make it then only we can make it as a production grade. Otherwise everyone can create this rag and all. Now whenever you are creating a rag now, guys, so just keep in your mind these particular points. It's ultra light, super fast, cost efficient, okay, based on a state of art, based on a state of art, right? So you can like forget this one, but yeah, this this one super fast and cost efficient, this two actually it is very important point. Now coming to the next point here, so I shown you this from the scratch, okay, using that particular code which this guy has created. And the next one basically from the langchain. So yes, langchain integration is also there. So let's look into the langchain solution. Now here, one more important thing, very important thing, guys, which I'm going to explain you in the next class, and then I will start with my retrieval series and all. So the concept is called the contextual compression. This contextual compression is a very important one, and like it's a very important functionality of the LangChain as well. So here I created one complete notebook for all of you. So definitely you can utilize this notebook for any of your solution. and this is one of the retrieval method, the best retrieval method. Now apart from this one, guys, here you will find out like different other technique and all. So in the next video we'll look into it. So let's look into the langchain solution now. So first of all, we'll have to install this langchain community. Then we'll have to install this langchain OpenAI here as a LLM model. I'm using this OpenAI model, okay, this GPT model actually from the OpenAI itself. Then here you can see, guys, I am going to set up my OpenAI API key, which I already kept where inside my notebook. I already shown you this in my previous sessions and all many times, that how to generate the key, how to keep it over here, so you can refer my previous sessions, right? So now the next thing is what here is my OpenAI key. Now this is my import statement: first text loader, then recursive character test split, OpenAI embedding, and files. Okay, this is my database, in memory database, because here I am going to create my RAG pipeline. Then I'm going to load this particular data. It's a very well-known data, okay, state of the union data. If you will search over the Google, you will get the complete detail of this particular data. So let me show you how you can get the complete detail and all. So search about it and see. Do one thing: state of union. Great. So this is the speech of the U.S. president. Okay. So it's a complete speech of the U.S. president, and here you will find out the complete detail with respect to this particular data. If you want to read, definitely you can read the history, formality. Okay. The delivery of the speech, regarding which, what, whatever. Right. So yes, I am going to load this particular data, and based on this one, we are going to ask the question to my LLM, right? And we'll retrieve the answer first of all. Okay, we re-rank it using the FlashRank, and finally we are going to pass to my model, to my LLM for the final generation. Now, here is my guys. Here you can see, not this one, this one. So here I'm going to be split my data. So the chunk size is 500. In every chunk, there is 500 token. So the overlap size is 100. Okay. Now here is my text splitter, where actually I'm passing my document. Now after this one, to each and every document, guys, I'm assigning to the ID. So here you can see text dot metadata. I'm creating a dictionary, okay, metadata dictionary, and I'm assigning a ID to each and every document. Okay, so I hope till here everything is perfect, everything is clear. If you want to check out with the text, definitely you can see. So once you will write the text here, you will get the complete detail and all. See here, it is giving you the ID. So sorry, it is giving the page content. This is the page content, and here is a id with respect to this content, okay, page content. Now I hope this thing is clear to all of you. Okay, it is not a text, it is text. So text basically will give you the complete all the document. See, here is the id and all, everything. Now coming to the next part. So after this basically chunking and all, what we can do, we can load the embedding model. Okay, this is my embedding model from the OpenAI itself. The model name is text embedding ADA002. Now I'm installing this 5 CPU. I haven't connected with my GPU over here, because I think I thought it is not required as of now, just for the simple task, right? So here I connected with my CPU. Now I can pass my data and this embedding model to my database. Okay, so I'm calling this files dot from document text and embedding. I'm passing my data plus embedding. Okay, so I will be get embedding model. So at the end, I will be able to store embedding. Okay, embedding where inside my database, and it's an in-memory database. Now, what is the database name? So the database name is Facebook AI Similarity Search. Right now, I hope this is clear to all of you. So what I'm calling this as a retriever. So once I will call this as a retriever on top of this database, so that I can utilize this database as a for the similarity search and all, right? So here I'm passing this search kwargs k is equal to 10, means once I will pass the query to this particular database, it will give it to me 10 similar document based on the rank, right? So here is my query, guys. So I'm asking, what did the president says about this Ketanji Brown Jackson? So this is a person, and related to this person, I'm asking the query. So I'm invoking the query. So it is giving me a document, guys. Here, see, I'm having top 10 document, and this document actually I'm passing to this pretty print, right? The function which I created, and now see how beautifully actually it has arranged all the document. So this is my all the document, guys. See each and every document I'm getting, and in total I am having 10 document over here. Now what I want to do after collecting it, I just want to re-rank this particular output. So let's try to re-rank this output. So first guys, here I'm importing this contextual compression retriever, and this is what guys I was talking about. This is very important thing like inside the langchain, which we need to understand, which we need to learn if we want to like create a most effective and the most robust like pipeline. Now here is my FlashRank. Okay, then here is my chat OpenAI for the OpenAI model. Now first I'm loading the model guys. Okay, now temperature value is 0. I can keep it anything between 0 to 2, but I'm keeping just 0. I will be getting a natural output of the model. That's it. So here I've defined my Flash Reranker, and this Flash Reranker actually it is my compressor, right? I just given the name as a compression. I can write any sort of a name, right? Now after this one, guys, here see, I am calling this contextual compressor retriever. Now what's the meaning of it? So this contextual compressor retriever actually what it is doing. See, just read it in a reverse order. So retriever means which retrieves something. It compress, okay, which is a contextual one. So it is giving you the answer. It is giving you the like answer, the retrieve answer, but the answer will be a compressed one. Okay, the answer will be a more contextual one. Now here it is taking two things. One is it is taking a base retriever, the retriever basically which we have created, which is giving you the 10 document, and along with it, it is taking a document compressor. This particular argument actually it is called the document compressor. So first of all, see this contextual comparison retriever. It is taking a document from here from this base retrieval, and then it is passing to this one, and finally it is giving you the compress output. So in the next video, I will explain you this in a more detailed way. Here I have created a dedicated notebook, but as of now, just think that it is giving you the more compressed and precise output. Got it? Now here, this is my compressor retriever. Now I'm invoking it with what? With the same query. So here, guys, I will be getting what? I will be getting the compressed document. Now let me show you this compressed document. So let me remove this particular part from here. And here, guys, you can see this is my document. Okay, all the document page content. Here you can count how many it is. I think we are collecting 4 or 5. Let me check with the length of it. So by default, actually, it gives you the 4. Let me check the length of it. What will be the length of this compressed document? So here it is giving to me 3. Yes. So 3 document we are getting. And now see here. If you will check now, guys. So see compressed document. Here is my document. I'm getting document, and this is my metadata ID. So first 73. The first document is 73, then second, and then 50. So it is giving me top 3 document over here. Okay, so previously actually we were collecting 10 document over here because we have mentioned k is equal to 10. I think by default it gives 3 document. Okay, so k is equal to 10. Now this was my k. This was my tell me how many document? 10 document. Now see the document, the ID of the first document. It was 73, then 79, then 74. Okay. Now here after re-ranking, guys. So by default I'm taking 3 document. Now see the ID. 73 is the first one. Okay, that is fine. Then second and then 50. So these are the re-rank document, top 3 document. Okay, after re-ranking, after a second stage retrieval. And here, if you want to check the document in detail, you can print it out. You will get the content also. Now what I'm doing, so after collect, see, yes, this is my document, guys. Document 1, document 2, and document 3. You can read it about it. You can read about it, and you can get the more detail. Now what I'm doing, guys, I'm creating a chain where I'm passing my LLM and I'm passing my compress retrieval. So this compress retriever will give me the document, and this LLM basically it will provide me a large language model. So what I'm doing now, I'm invoking my query, and here guys you can see the answer. This answer basically it will be a more precise because here actually we are giving a precise and the compressed information, the specific information to what to my LLM model. So yes, I'm not going to longer this video more than this one because yes, you can check out with the different queries and all. I will give you this particular data set, this state of the union text. You can generate a different query, you can test it out. If you are working on any POC anything, you can take my help. Okay, you can use my solution, you can do some manipulation in my solution and all, and definitely basically your project and POC will be selected, and even you can mention this type of thing, this type of work inside your resume as well. Okay, so fine guys, thank you. This is it for this particular video. Now in the next session we'll discuss something new. Until guys, thank you, bye bye, take care.